Welcome to RETeval report interpretation of the Flicker 16 Troland and PhNR tests. Just to recap, electroretinography measures the electrical responses of various cell types in the retina, including the photoreceptors, inner retinal cells, and the ganglion cells in response to a stimulus. This illustration shows how light travels through the eye and the retina and how that corresponds to the ERG waveform on the right-hand side. The ERG waveform is represented in time on the x-axis in milliseconds and amplitude on the y-axis in microvolts. As light travels through the eye and through the layers of the retina, it triggers an electrical response in the photoreceptors, which you can see here on the waveform is indicated by this A wave, this first peak here. As the electrical impulse travels through the retina from the photoreceptors to the bipolar cells, it triggers another peak here, which is called the B wave. And then as the electrical impulse travels from the bipolar cells to the retinal ganglion cells and out through the optic nerve to the brain, you get this third peak here called the photopic negative response. And then the waveform returns to close to zero as the signal leaves the eye. The first report we're going to review is the Flicker 16 Troland test, which is generally used for patients who either have diabetic retinopathy or are suspected of having diabetic retinopathy. As you see the report, the first piece of information at the top here is that is blacked out is the practice information and address. The second piece of information also blacked out is the patient ID. The third piece of information is the birth date that's been put into the RETeval device. It is important to get the birth date correct because the device compares the results to an age-related normative database, and it's important that we're comparing versus the right age group. The next piece of information is the test protocol. In this case, it's the Flicker 16 Troland test. Troland tests are done in patients who are non-dilated, but they can be done in patients who are dilated or in any state of dilation. The first legend here indicates time, and time is implicit time is that are in yellow or red indicates slow implicit times, and slow implicit times are generally bad, and they indicate that some sort of stress is occurring in the retina, and 95th to 97.5th percentile will be flagged as yellow. 97.5th percentile, the 100th percentile will be flagged as red. The opposite is true for amplitude. Lower amplitudes or lower amplitude strengths are indicated in red or yellow, and that indicates generally cellular damage or cellular death. The next piece of information I look at on the report is these photographs of the eye that were taken by the device during the test. And I look at these to make sure that sensor strip placement is correct. And so on the right eye here, it looks to be in the correct place. In the left eye here, it looks to be in the correct place as well. There are two waveforms indicated on this report, right and left eye. The top waveforms are the fundamental or line of best fit for the waveform, and the bottom two lines are actually the raw waveform for the right and left eye. Which you choose is up to you. I generally tend to look at the raw waveforms. Now, the device takes about 50 different measurements or flashes during each test or each eye, and the device will throw out any blink artifact, any bad measurements, and these waveforms here represent the average of all of those measurements. The next piece of information I look at is waveform amplitude. This generally indicates retinal health, and a strong response or a response in the green indicates that generally you have a healthy retina. In this case, right eye, 21 microvolts or 50th percentile, just about average. And in the left eye, 16.5 microvolts or 27th percentile, a little bit less than the right eye, but still well within the green. So this to me indicates that this retina generally tends to be healthy. There's a good response. However, the next piece of information I look at is the implicit time. And in this case, the implicit time in the right eye is significantly delayed, 34.4 milliseconds, 100th percentile, 33.9 milliseconds, 99th percentile. So relatively slow compared to the normative database. In this case, I would be concerned because this generally indicates that something is stressing this person's retina. So if this were a patient that had diabetes, I may be worried that this patient might be developing diabetic retinopathy. If this patient had diabetic retinopathy already, I would be worried that they could be getting worse. In this case, you might be able to see this patient on a more frequent basis just to keep an eye on their condition, or if you're very concerned, you might want to consider either treating this patient or referring them on for treatment. What's interesting about this technology is you can see this delayed implicit time and this stress on the retina before you actually start to see damage in the eye with structural measures such as OCT or fundus photographs. So you might be able to pick up changes earlier than you would normally see them on these structural diagnostic tools. This next report is the phototopic negative response report generally for glaucoma patients. In this case, there was actually 2 tests taken on each eye, and you can see that with the different colors. The green indicates the first test, the orange indicates the second test. Most people will do 2 tests on this particular report. You can see that both tests pretty much overlap each other, the waveforms, and that indicates a good reliability, a good consistency between measurements. The first test results are indicated on this first line here. The second test results are indicated on the second line, and the third line indicates the average of the 2. I always look at the PhNR at minimum on both of these eyes. First thing I look at is the implicit time in milliseconds, what you're looking for times that are not slow. And in this particular case, 19th, 15th percentile on the right eye, 33rd, 10th percentile on the left eye, well within the green, good responses here. If these were values were highlighted in yellow or red because they were significantly slow, I would be concerned that this patient may be developing glaucoma. As I mentioned before, implicit time indicates, delayed implicit time indicates cellular stress. If these numbers were highlighted in yellow or red, this would indicate significantly delayed implicit times, and that could indicate that something is stressing these retinal ganglion cells. And so if it were a glaucoma suspect, I'd be worried they could be developing glaucoma. If it were a glaucoma patient, I'd be worried that their glaucoma could be getting worse. This is also a number that you could look at over time. So if you're seeing a patient every 6 months, every 12 months, you could say, hey, is it their implicit time getting worse? And if it is, that could indicate that their glaucoma could be getting worse. The next thing I look at is amplitude. And for this particular patient, there's fairly strong amplitudes, 76th percentile, 64th percentile in the right eye, 36th, 45th percentile on the left eye, both well within the green. A little bit of asymmetry between the 2 eyes, not too much that I'm concerned. This is a measure. If it were in significantly lower and it was in yellow or red, I'd be concerned that there was already damage that has occurred in the eye. And you may already see that in some of your structural diagnostic tools. I would look at this amplitude over time, and I would see if it was getting worse over time. So measure 1, measure 6 months later. If the amplitude were getting lower over time, that could indicate that things are getting worse with that person's retinal ganglion cells. The last measure I would look at on this report is the W ratio. And the W ratio is an indication of how well is the electrical signal transmitting through the different layers of the retina, from the photoreceptors to the bipolar cells to the retinal ganglion cells. And if the W ratio is closer, the closer the W ratio is to 1, the better. That indicates more of the signal is being preserved as it's traveling through the retina. So the closer to 1, the better. If it's over 1, that's actually really good. So that I would look for that. This is another measure I would look at over time. If that W ratio is getting lower over time, less than 1, then I would be concerned that the retinal ganglion cells or the retinal cells are stressed and are being damaged. So that would be an indication to me that in a glaucoma patient or a glaucoma suspect that they could be getting worse. So thank you very much. If you have any further questions about report interpretation, please feel free to reach out to your LKC representative or your authorized LKC distributor. Thank you.